Let's wait 2 more minutes for other students. Mr. Muhanna, inshallah we will discuss the homework in the coming sessions. For now, inshallah, we'll look into the module of our regular meetings. We have the today meeting number 5, and we'll see inshallah after completing meeting number 6, or hopefully inshallah in the next meeting we will see the homework and how to solve the homework inshallah. Okay. Amal, Najjar, this is not T103, this is TM111. T103, inshallah, next week from 2 to 4. TM113 or TM113 يكون الأسبوع الجاي. هذا الأسبوع اللي جاي. الأسبوع الزوجي. هذا الأسبوع الفردي. الأسبوع الجاي هي الأسبوع الزوجي. وعندنا TM103 الأسبوع الزوجي من 2 إلى 4. يعني 2 to 4. There is one student login by dot. Can you share your name, please? We need your ID number and name to mark your attendance. Those who have logged in just by their name or without ID number, please re-log in. I see even there is Tariq without ID number, and there is one man with dot. So, Mr. Tariq, can you please log in again by using your ID number and name? Okay, that will be good for me to mark your attendance. Okay, Mr. Ahsan, no problem. You can attend with me, inshallah. That's fine, inshallah. I will mark your attendance in the system. At the same time, you can inform your teacher just to make sure. Okay, now let's start with. You're welcome. Now let's start with today's session. Today, inshallah, we are starting with part number 5 of block 2. Okay, it's about modular programming. So today's discussion is on modular programming. What is modular programming? How we create modules in the programming? What is the necessary why it is necessary to have modular programming, and so on. What is al-Murai? What is al-Murai? TM103 is on next week. It is next week on from 2 to 4 on the same day. Next week Tuesday from 2 to 4. Okay, coming back to our topic today, inshallah, we are discussing modular programming. The introduction to this is, so far in the course you have gained some experience about structural programming, in which we have seen sequence, selection and repetition. So using this sequence and selection and repetition, we can easily write programs. We can easily write the scripts. And you also saw in the lab sessions how to use this. For example, selection. We have the selection statements. If else. So we use that selection statements to make any decisions, to execute the statements based on the decisions or based on some conditions. We also have repetition that we took in our last meeting. So what are the repetitive statements we have in OU build? Students online. Students online, I'm asking a question here. What are the repetitive statements in OU build? Students online? Yes. For loops. In OU build, we are talking about the loops in OU build. Repeat block we have. There are three. I give this. There are three blocks repeat for repetition. What are those three? Yumna, no. If is a selection, not repetition. I'm asking about repetition. Three repetition blocks in OU build. We took this in the last meeting, if you remember. Forever, very good. Still two more we have. Repeat until, very good. Mariam says until, yeah, it is repeat until. And the last one, repeat number of times. Like repeat 10, repeat 2, repeat 3, that is repeat number of times. So we have three repetition statements in OU build. This we have already studied till our last meeting. Now in this meeting we learn about nesting programming structures, how we put if inside the loop or repetition, we put the repetition inside the if or repetition inside the repetition. That's one thing. Number two, we are going to learn inshallah problem solving with custom blocks by creating modules or blocks. Practice using your problem solving skills and apply the programming idea. So we'll take one case here, one problem here, and we apply the idea of modular programming, designing the program and writing the script, okay, writing the code. So that's our main thing here. The main interest here is the problem solving by using the modular computing or by using the modular programming. Nested structure, we can put, a structure inside another structure. For example, if inside if you put, we call it as a nested if. Loop inside loop or repetition inside another repetition, we call nested repetition or nested loop. Okay, so these are important in programming when you want to repeat a certain things a certain number of times. Okay, and you want to repeat something based on some conditions. Fine, we are going to use these kind of things in case of repetition. For example, if you see this script, there are two loops here. One is called the outer loop, which is a forever loop. So this is an outer loop. This is a forever loop. We have another loop inside this, which is called repeat until loop. Repeat until loop or repeat until. Okay, the repeat until comes under the forever. Under forever. So the inner loop. What is the inner loop here? Can you identify the inner loop? Yeah, the repeat until is the inner loop, and the outer loop is forever. So forever is the outer loop, and repeat until is the inner loop. Very good. So the inner loop is formed by repeat until block. It makes the shark chase the octopus. That is, repeatedly move the shark towards the octopus. Okay, as if like it is animated by in this code. Okay, so the inner loop point towards octopus and wait for 0.1 second, move 15 step. So it is gonna move the shark towards the octopus. Okay, the inner loop, and we have the outer loop. The outer loop is forever loop. It makes the shark chase the octopus repeatedly forever and ever until you close it by yourself or you ask to stop the script. Okay, so the outer loop has the forever loop. So that's about the nesting the programming structures. Fine. So any program you can nest the or you can add one structure into another structure, whether it is a sequence structure or whether it is a repetition structure or it is in sequential structure. You can add one kind of thing, or you can say you can add one particular action inside or one particular repeat statement inside another repeat statement, or one if statement inside the repeat statement. Fine, so you can add one structure inside another structure, so that will help in doing the programs in more efficient way and understanding the programs and easy to do the programs. Now, moving on to our next topic, that is reducing the complexity of the program. Reducing the complexity of the program. Some complexity is programmed is expected, and some complexity in programming is accepted. We don't say that every time the program is easy, there is no complexity in programs. Okay, there's some kind of complexity you will face in the programs. If you are an experienced developer, you will face the big task and the complexities in it. And if you are a beginner, you have a small task, but there is also some complexity in the program. And if you want to do a program and interesting and complete the task, it is expected that it will not be short and straightforward. You don't expect that the program will be straightforward to you, and you simply do the program and give it to the client, right? So there is some kind of some kind of complexity you are going to expect inside the program. There can also a possibility that you will not get the program right straight away. After you reading the program problems, you may not get the program in a straight away, and you may not get the program in one shot. You need to repeatedly read the problem, ask your friends, or ask someone who was in this field and make the corrections or try to understand the problem. So there is a possibility that when you read the problems, you may not get that how we can do this, these problems, how we can implement as a program or as a software. However, there are some techniques that can help you to manage the complexity by structuring your program into parts so that it's simpler to create and understand afterwards. So one way to reduce the complexity here is to divide the program into parts. Divide the program into parts. That is called the modules. So the basis for this is to make a block facility for creating custom blocks. So a block facility for creating the blocks. So we can use these block facilities to write the program as a part of the program, not the complete program. And later we can combine the all these blocks or modules together to make one problem solution. One problem solution. So when you structure the program into parts, then they are simple to create and understand. The basis for is to make a block facility for creating custom block, creating a block to implement the tasks needed in several scripts. That the single block can be used in those scripts rather than duplicating the code. So no need to duplicate the codes. It is just copy the codes, fine, into another module, into the other modules. Creating a block to implement the task, as I said, is several scripts that is signed. Single block can be used in those scripts. You see here, we have two blocks here, wake up block and go to sleep block. Wake up block and go to sleep block. Now what are these blocks? It defines wake up, for example, switch costume to wake, change the color, effect by 50 and play the sound. And go to sleep, switch costume to sleep, clear graphic effects. Clear graphic effects. Now these are two modules which are used inside the program. So whenever we write this wake up, this will call this module, execute all this. After finishing this, it will go to the next task. And similarly, whenever we call go to sleep, the go to sleep is block code is executed, go to sleep block was executed, and what are we have two statements which are executed in this place. Fine. So this is how we make the blocks or you can say the functions in the programming. So blocks are important. We can reuse the blocks. For example, once I write the wake up block, I can use this wake up block in any scripts, in any programs to do the same job. Similarly, once I write the block go to sleep, I can use this block for any kind of programs, for any kind of program that has this the sleep option, go to sleep option. So there my code is executed whenever I call this module. So this is how the modules are created in the OU build. You can also create your own modules in the OU build. Okay, you can also create your own modules in OU build. So here we have show high mix costume pickup. Now we need to create the modules. Here it is, make a block. Okay, whatever the name, you can give them a block name. Okay, so for example, I'll give this as test module. Okay, now this is a test module. So I'm defining a test module where I can add some code which is executed whenever I call this test module. Right. So I put a hello. I put this is my test module. This is my test module. Okay. Now in the events, when you click this, go to the modules, you have call this test module. Fine. So it will call the test module, which is calling this and executing this. Okay. So in this fashion, we see that modules can be added. Whatever that you want to add code inside the modules can be easily added. Instead of having duplicate code for waking up and going to sleep, when we execute this code, in this example, we just create one module and we are calling that module. The advantage of having this module is that we save the time and effort and space. Save the time, effort, and the space, because every time we call that module, the code of that module is executed. The code of that module is executed and reduce the risk of errors, because if there is any error, we will correct inside the module. We're not going to change the basic program or the other script. Right? So we reduce the risk of errors. And the last one, make the structure of the code simple and hence easier to understand. It is more reliable, easy to understand. So there are some advantages of having modules. Okay. We are coming back again to the nested loop inside another loop. It is the same thing. For example, if you look into these two statements, right? So we are using the loops here. But it's not nested loop, but we are using two loops, repeat eight times, right? Making some changes to the graphics. Making some changes to the graphics. Nested loop is called when loop comes inside another loop. We call that as a nested loop. For example, if you want to draw something like this, we have to use the nested loop. We have to use the nested loop. So as you can see on the screen, we have loop inside another loop that is called the nested loop. The repeat 6 is called the outer loop and repeat 8 is called the inner loop. So that's about the nested programming. Okay, the next part here is modular programming. Before we move to this modular programming, I just want to ask you, do you have any questions on nested programming? Repeating of the loop, any question? How about the other students? No questions. Okay, the next topic here is modular programming. Modular programming is concerned with creating programs organized as relatively small modules that work together which achieve the overall task required for the program. Okay, so in modular programming, we are dividing the whole program and organizing the whole program into small modules which together achieve the overall task, which together achieve the overall task or overall job. The modular programming enables the programmer to focus on program at various levels in detail in more structured manner. The results in the code or the core of results in modular programming is the it is by combining all the results of all other parts of the programming. Okay, it is easier to create. The modular programming is easier to create, easier to understand. Okay, so with our modular programming, it is easy for us to create the programs with very few errors because the programmer can concentrate on implementing the small task at one time. Easier to understand because the structure of the code is clear to everyone. Because it is a small program, the structure will also be the very small and easy to understand. With the help of modular programming, we achieve reusability of the programs or of the scripts. Reusability of the scripts. Professional developers are concerned with potential for future reuse of their components, as well as how components may simplify their current program. They want their component to be easily reused in future. Forming a clear specification is one aspect of this rejection. So here it is looking into reusability of the modules or of the codes. Okay, so don't need to write repeated codes again and again. Just make the modules and call the file names that will that make sure that the code is reused. Fine. So reusability is one of the feature in modular programming. Refactoring is a program concerned amending its structure to improve it while not changing what it does. It does not change what it does. It does not affect what it does, but it affects the structure. Sorry, it does not. It concerned with amending the structure. Fine, to improve the structure, to improve the visuals, but does not change what it is doing. And to the user, the program behaves identically, but inside the program, the code may be reorganized. Okay, to understand it much better and to discuss it much better. So that's refactoring. So these are two features again you can consider for the modular programming, reuse and refactor. We also have uh, the what you call in modular programming. We also have the other features. Fine, saving the time complexity is reduced, and the other programming things what you can learn. So that's about the modular programming. Problem solving in action. As a problem get more complex, we need a technique to break down the problem, solving the problem into smaller parts that can be easily managed. Sub-processes may be identified which represent important distinct tasks. Each sub-process can be implemented as a component. And by doing this, we simplify our programs. Excuse me, just give me 2 minutes. I'll take some water and come back. I'll take some water and come back. Okay, just give me 2 minutes, inshallah. Okay, welcome back. So we're talking about problem solving in action. So how we can do problem solving by using modular programming. So as problem gets more complex, what we will do is we need a technique that we break the problem into smaller parts which can be managed easily. Now these smaller parts of the problem can be easily managed, can be easily solved. Fine. So this can be a different task, or you can consider every small part as a module, as a or as a part of the program. Now each sub-process can be implemented as a component, as a separate component, and with this one we can simplify the problem. We can simplify the whole problem. So it is very simple, like we see, for example, this is one big problem. Fine. So to solve this big problem, okay, it's very difficult, that we solve this problem and to solve this problem from top to bottom. So we what we will do is we break this problem into smaller pieces of the problem. Okay, and so that in every piece we can solve it in separate. So we'll take it as in module A, B, C, D, E, F, G, H, I. So we'll take it separate. For example, the module I, we'll take it module I, we solve this, okay, and we have the solution for module I. Similarly, module E. So we have the module E with us. We solve this module E and we have the solution. So in this way, we can solve the whole problem in a much easier way compared to like you are solving the problem from the beginning till the end. Fine. So this is what the modular programming you can say, or you can say that divide and conquer rule. Or we also say this as a divide and conquer, dividing the whole problem and combining the results. Fine. So with this way, we can just simplify it. Like the problem will be more simplified. We can solve the problem in more simplified way. So designing the components, once we decided like, okay, we are gonna break this whole problem into components. The next job here is how do you design these components? Okay. So these problems, can be identified early in designing the algorithms. When you try to design the algorithms, for the problem, for the components, for every components, you can simply design it for the components. This can also be sometimes identified later that there is a component here, and we can identify that later also sometimes. Okay, some people prefer to give more detail to a complex algorithm before thinking in terms of sub problems. Okay, dividing them. Fine. Both personal preference and the form of the specification influence the design process. Okay, so it means what you think, what you want to do, whether you want to divide the whole problem into small components and solve them, or you want to solve the problem as one. You don't want to divide it, you want to go for one problem. This is all, it influences. It also influences the way the problem is, the big the problem is. Okay, so it's up to the programmer as well as the program itself that makes give us a chance to make a decision like whether to divide the problem or whether to keep the problem as it is and solve the problem. But it is always a good practice that you divide the problems into smaller components as easy as possible and solve them as easy as possible and use those components in your program. So that will be more efficient and it will be more reusable. Okay, and you can see that things will be easy when you divide the whole problem into smaller parts and you solve the problem. Then after you come up with a design, Then we will move for the implementing the components. So what you will do when implementing the components? In implementation of the components, what can be done? So partition of the process involved in algorithm into smaller, more manageable sub-process makes the algorithm design process simple. When it is involved in more complex, retaining those sub-problems a distinct part of the final algorithm can make the algorithm itself easier to understand and then to implement. So the thing here is that when you divide the problem, okay, it's easy to understand and easy to implement. So the implementing the component is also made easy by dividing the problem. Okay, a bottom-up approach. A bottom-up approach, what is a bottom-up approach? Bottom-up approach is that you divide the whole problem into components. After you divide them into components, then you implement every component separate, test them separate. The components which are not independent, which are not dependent, are tested in separate, and which are dependent are tested with the dependent component, and then they will be combined into one script, which is called a bottom-up approach. So if I draw a figure for this, it will be something like this. For example, let's say that we have this big problem. Okay, this big problem is now we're going to divide this. Let's say this problem is problem P. Okay, now we're going to divide this problem into some parts. Okay, we name it, for example, let's say this is block A, this is block B, block C, block D, E, F, G. Okay, these are the components of the problem P. So we make different components. So let's say there is a PA component, there is a PB component, the component B, there is a PC component, there is a PD component. All these are components from the problem P. So we divided the problems, okay, and we make the components here. Fine. So we break the whole problem into smaller components, and we see that it is easy for us to solve these components. We get a solution to these components. Okay, we got S as a solution to these components. Fine. Now after we getting the solution to these components, okay, the next here is that we need to test this whether they are working fine or not. We see that some of the components are dependent on others, some of the components are independent. Like for example, if you set a component A, this is separate, independent. So you can test it separately to check whether it is working fine or not. Okay, we also see that component D is in separate, so there is no dependency. We can test component D in separate and easily. We also see that, okay, there is a component C which is, it is dependent on B, it is interactive with B. So when you test B and when you test component C, fine, in separate. At the same time, you need to combine them, okay, and test after combining them whether they are working fine or not. So now why to test this after combining them? Because there is some interdependency between the components. There is some interdependency between the components. Now after doing all testing, we are coming up with the solution of A, then solution of B, then solution of C, okay, solution of D, solution of E, solution of F, and all. So as all, we got the solution to the problem. We combine this all into one solution. What is the solution for the problem? Okay, so this approach of dividing the problem into smaller components, implementing them, divide it, implementing them, okay, and then test them and then combine them to make the solution, the whole solution. We call it as an bottom-up approach. Fine. So bottom-up approach is individual component need to be implemented first, checked and tested. Finally, the whole program is put together. So in general, it is sensible to implement first any component that do not dependent on the result of other component. Then to implement those only depend on the result of other components. Okay, and so until all components are implemented, scripted, and created. This approach we call it as a bottom-up approach. Right. So this is designing the solution of the problem. Finally, we talk about testing and debugging a complete program. Once you combine all these, the next job here is testing and debugging the complete program. Right. So the bottom-up approach applies also testing complete programs which contains newly created components. If you simply test the overall program and test fails, it can be hard to locate where is the problem, where the test fails. Okay, it is it in the component or in somewhere else? Instead, we can start testing each component at the beginning. Again, we test them after they check their dependency and make sure that each of them work correctly. If not, then we can correct the problem. Then we can see that where is the problem and we can correct that problem. Once we have tested and if necessary debugged our component, then we can progress for testing the overall program. Fine. It means that once we did test all the components, finally we can combine all them and test the whole program. When testing complete program that involves already tested component, if test fails, then there are some common errors that we need to look for. The wrong components may have been used, okay, or the right one may have been used in wrong order. Data upon which a component depends may have been set incorrectly, or incorrect data is supplied to the components, and component result may have been used incorrect. Some of these mistakes, so may happen when you see the test goes wrong. When you test the whole program and you see that there is some mistakes, so the common errors can be these: whether you use some wrong components in wrong place, or you put the wrong order for the components, or you supply the wrong data to the components. Okay, so these are common errors in testing the final program, and if you find any errors, it can be from these. Okay, so this is about the whole problem solving technique, what's called the bottom up approach technique, where the problem is divided into smaller components. These components are implemented, tested, again the solutions are combined into one whole script and tested again to make sure that the program works perfectly. So in simple steps, it is like this. First, the whole problem is divided, okay, into smaller components. Okay, these components are implemented and these implemented components are tested. Fine, they are combined. After combining, they are again tested, and it comes past the test. You get the solution. You get the solution to the whole problem. Fine. So this is how the bottom approach works, the problem solving technique works, and we can use this problem solving technique to solve any given problem. Okay. Now is it clear the concept of problem solving? Students online, is it clear the concept of problem solving? That's good. So with this concept of problem solving, we can solve any type of problem. Okay. Now we'll take one example problem. We'll take one example problem, and we'll see that how we apply this concept of problem solving, designing components, okay, and finally we test them and we solve the problem. Fine. Now let's consider this problem. I'll give you 2 minutes. Please read this problem. Take 2 minutes and read this problem. Okay. Now I hope you understand what is the problem here is. That here the problem is my grandson wanted to know the names of the birds he saw in my garden during this morning. I told him to think about the bird and describe what he saw. He said the first bird he saw were different colors. Two of them were brown and but different sizes. One was blue and yellow. Okay. Now here, the problem here is to find the name of the bird. The problem here is to find or to guess the name of the bird based on the description given. Based on the given description of the bird. Now the bird is described as based on the colors and the size. colors and the size. Now let us analyze this problem. We analyze this problem and we write some description about the problem. See, what we are doing is an example of what we just took as a modular programming. Okay, and even you carry this idea to your next courses, to your next assignments, to your project. Okay, that how you solve the problem. So here we make an analysis. I explained that large of two, that the larger of two brown birds was song thrush and the smaller brown birds was a sparrow. The blue and the yellow bird, which was about the same size as the sparrow, was a blue tit. Later on, another bird appeared that was about the same size as the sparrow, but although it is mostly brown, it had a red chest. I told him this was a robin. Another bird of the same size sung thrush, but black all over. This was a blackbird. Finally, two much larger birds came into the garden and scared them small bird away. One of these was mainly black, but had some white on it as well. This was a magpie, and the other was a gray, blue, and pink, and was wood pigeon. Now here we are analyzing the problem. We are describing that on what colors and what size, which is the bird. Okay. For example, it says like we have, for example, sparrow. The blue and the yellow bird, which is about the same size as the sparrow, is a blue tit. So if the color is blue and yellow and the size is, the small, then it is what we call blue tit. Okay. And to large bird, the smaller bird, brown, was a sparrow. It means a small and brown. The color brown and the size is small. It's a sparrow bird. Okay. So we are taking all the description of the birds here. What the bird is called, what is their colors. For example, if I give yellow and black and the size is small, then what can be the bird? Fine. So we analyze the whole situation here, that what can be the birds, fine, and their description of the birds, based on which the decision is taken. Okay, I found a bird field guide with pictures of the bird as you see in the figure, and we see that okay, with the yellow and blue tit we have a brown bird which is called a small sparrow. This is a robin and this is song thrush. This is a blackbird and magpie and wood pigeon. Fine. So with their color and their sizes. Fine. So we got this. Now we want to design an algorithm for this that says what is the bird based on the size and the color. That is the bird based on the size and the color. Okay, in designing the algorithm, we'll start with there are two types of facts here. One is the size and the color. Two facts here we know, that is size and the color. With the bird described here, knowing whether the bird is small, medium or large, knowing the color of the bird, we can identify the bird. Okay. Now simply what we write here is the algorithm, okay, is input the facts about the bird, okay, then decide the name of the bird based on the facts, and then output the name of the bird. Very simple, right? the simplest algorithm, we can say that you give us the fact or input the fact about the bird and decide the name of the bird based on the fact and output the bird. This is, a general description you can say about the algorithm. The situation is complex to write down in words, but in these situations a diagram helps. Fine. So selection is to decide the bird name based on two facts, based on two questions. One is what is the size? The second question is what is the color? That what you input. So what we can do is we can draw an picture or an flowchart for this to show that how this will work. In writing this simple algorithm in 3 lines of algorithm, it's very easy. Fine. But we need to decide based on some selections. We need to based on some questions. Okay. So we decide to draw a decision tree, making a decision of which bird it is based on some questions. Okay. So we decided something like this. What is the size? First we ask what is the size? Small, medium or large? So you will answer what is the size. You say small. Then we ask what is the color. Then you decide about the colors. So if you are telling that okay small and then brown, then we can conclude and we can decide that it is a sparrow. Right? Let's say you said like it is a medium color, medium size and said black, then you said it is a black bird. Said it is large, and then what is the color? You said like it has some gray, blue and pink, then we say it is a wood pigeon. Okay, so this is a decision tree that shows like how the solution will go, okay, based on the facts what you are entering. Now based on this tree we can enlarge our algorithm, we can extend our algorithm. We can refine our algorithm. We say that okay, input the size, input the color, use the size and color to decide the name of the bird and then output the bird. So in inputting the size, we ask like what is the size? Then we say like if small size, then we ask input the color, decide the name. Then if it is medium size, input the color, decide the name. And if it is large, input the color, decide the name of the bird. And finally, output the decided name. What is the decided name of the bird? Okay. So you go in more detail of it. Fine. So my algorithm here is quite complicated. So I review it. It was quite complicated. Then we reviewed it and we decided, to have different processes based on different sizes. Okay, different blocks. We made sub processes based on different sizes. Okay, so we can say that okay, we have different blocks here. For example, if it is a small bird, we make a block of identifying the small birds. If it is a medium bird, we make a block of identifying the medium birds. If it is a large bird, we make a block of identifying the large bird. Okay, what is the large bird here? Fine. So identify the small bird. We go into now components. We are designing the components now in detail. Identify the small bird. So this is a small bird component. Fine. Input the color. If brown and red, then robin. If brown, then set the name sparrow. If blue and yellow, set the name blue tit. Okay. Number 2, identify the medium bird. Now this is a medium block. Medium block. Input the color. If it is brown, song thrush. Set the name as song thrush. And if it is black, then it's blackbird. And this block is the large block. where you enter the color, black and white, it is a magpie, otherwise it is the wood pigeon. Right. So we got three blocks now from the whole problem. The small bird block, the medium block, and the large block. Fine. So three blocks we made it. Now how we implement it is that first we asked it what is the size of the bird, and based on the size we call the blocks. So we say that if size is equal to 1, you enter the size first, you set the size to answer the size is 1, you call the block identify small birds. So there is a block identify small birds which will ask you the color and set the name of the bird here. Okay, and if you enter 2, that is the size is medium. So you have another block called medium, identify medium bird. Okay, there you ask the color and set the name. And if you are entering 3, then you have another block called large, where you identify the large bird based on the name, and that will set the name of the bird, and finally you say what is the name of the bird here. Okay, so your input is first the size. Based on the size you call the block or the module, and inside the module you ask for the color. Based on the color you set the name of the bird and you print the name of the bird at the end of the program. Okay, so with these three different blocks we implement it as like this. We implement it like this. Fine. So this is about the modular programming, dividing the whole problem into smaller problems and designing them and implementing them, right? So this is what is we have here from this meeting number 5. I think the idea and the concept is more clear with the example. Do you have any questions on it? No questions. That's good. So overall, as a summary of this meeting number 5, we have seen the nesting of selection and repetition, that is nested loops, and how we can put inside the loop the if block and the if inside the if the loop and all. And we saw about dividing the whole problem, modularization of the problems, dividing the problems into smaller modules, designing them, testing them, and implementing them. Inshallah, on Thursday, we'll try to implement this whole problem. And on coming Thursday after tomorrow in the lab session. Okay, so this is all what we have for today. Before we close, let me have your attendance first.